Evaluate the trigonometric limit. Yeah, this can be quite a problem. We're given this hint, so at least that's a good thing. Usually with trigonometric limits, you need to know trigonometric identities. And in this case, let us first, before we take the limit, play a little bit with the expression for the trigonometric mix that we have. It's mainly trigonometric, but there's of course a 1 over x here. So in fact, the first thing we'll be using is an identity, which is the following. So 1 minus cosine of 2 theta divided by 2 gives you sine squared of theta. I think that was missing. Now notice the difference between thetas here. So if this is 2 theta, then this is theta. Now here we have this is x, so it's 2 times half of x, and so this will be half of x. I'm just pointing it out. We still need to work a little bit with it. So before I can do anything, actually, I need to multiply and divide by 2. So I need to substitute, I need to divide by 2, but then I have to multiply by 2 also, because otherwise it's not a true statement that y is equal to this expression. But if I multiply it by 1, which is equal to 2 over 2, then I am good to go. And then in that case, the first expression, which I'll probably color in blue, will be equal to sine squared of x divided by 2. It's very important. And then we have the 2. And then for x tan x, I'll write this 1 over x. And for 1 over tan x is interesting. So tan of x is originally equal to sine of x divided by cosine of x. So if I consider 1 over tan of x, then it's the opposite. It's cosine of x divided by sine of x. Because I flip everything. So instead of tan, I'll write cosine of x divided by sine. Okay, what's next? Well, we still haven't used the hint. And here we have 2 sine functions. Let me be very precise. So by 2 sine functions, I mean it's sine x over 2 times sine x over 2. To really emphasize this, I'll actually write it twice. Oh, so literally, yeah. Times sine of x over 2. Maybe I'll give myself a little bit more space. Now, if we want to take the limit, then we want to have the angle. So as you can see here, we want to have the angle divided by. And so this is actually something we can achieve if I just simply write. So for the first one, I'll give it the x that we already have in green. I'll give it one of the x's we have. That will be x. But then I will divide by a 2, so that's extra. And we need, in the very end, we need to make sure that everything we're adding, we remove it again. So I'm divided by 2, I need to multiply by 2 to get 1, for example. This is the same multiplying by 1 trick. For this limit to work, I also need to divide by x over 2. So that is good. And now notice that if I am dividing by 2 twice in the denominator, then I am dividing the denominator by 4. because it's 2 and 2. And if I'm dividing, so if I'm multiplying the denominator by 1/4, so this is equal to 1/4, 1/4 times x, then I'll multiply the numerator by 1/4. And I'll also multiply it by x. So notice now that if we multiply the red part here, we get x/4, and here we get x/4. So everything is good. This is just multiplying by 1. Now we know that if we take the limit, this will go to 1. Sorry, yeah, it will go to 1 by this definition. And if I take the limit of that, this will also go to 1. Then I have to deal with these two. I have x and I have cosine of x divided by sine of x. Then I'll do something that's very nice. So I hope you don't mind if I just put the cosine on the side and I put x divided by sine x like this. So for cosine of x, we can plug in 0, right? So if we plug in 0, cosine of 0 is 1. So that's good. So we just need to deal with this part. And this is actually very simple because this is the hint once again, but it's in reverse. So x over sine of x, if I take the limit, it's the same thing basically. Because x over sine x is 1 over sine x over x. And if I take the limit of this big thing, the whole fraction, it's effectively the same thing as taking the limit in the denominator. But then the limit is equal to 1. So it is also 1. That is also another trick that we use. So it's nice. It looks like everything goes to 1 very nicely. But then let us not forget this 2, which was originally there from the start. So maybe I'll give it a 4th color. To distinguish between the red ones. Okay, then at least we have an idea now, and we can take the limit as x tends to 0 of this whole thing. So the constants can go outside. We don't really need them. 2 divided by 4. This is the first limit. The limit of the product is the product of the limits. So I can write this as follows. And then I can even write it as a third limit. And even as a fourth limit if you want. It really depends on what you want to do. These are 4 different limits. You don't have to do this, but I like to break down my problem into simple bits. So here we have a half. The first limit is equal to 1 by the hint. The second limit is exactly the same value. Third limit is it's 1 over a limit as x tends to 0 of sine of x divided by x, which is equal to 1. So this is equal to 1. And then finally, we have the final limit, which is, you can just plug in, right? So it's cosine of 0. And cosine of 0 is also equal to 1. So after this very long sequence of ones, we get that the answer will actually be 1/2, which is 2/4. Now a common question is, how do I even start solving this, right? And the answer really is you kind of don't until you do. So with some problems, it is difficult to accept, but you just have to see it for the very first time. And when you see it for the very first time, you understand it. You see it for another time, you start to get familiar with it. You see it one more time and you're like, okay, I'm seeing a pattern here. This is similar to the problem that I did in quiz 3, for example. That was with the limit and this, and that. This is done. And so on and so forth. So as long as you expose yourself to enough problems, then this should be easy for you. Key really here is practice.